Hey everyone, we're going to be doing, oh, this is Miss Lloyd, by the way. In case you didn't know, I feel like you hear my voice and you're like, oh God, this lady once again. Anyways, we're going to be looking at some functions and some of the things we can do with these functions. So I talked before about the vertical line test in my last video, and it's we're drawing this vertical line to make sure that it doesn't intersect our graph at more than one point. If it's more than one, it's not a function. We also, when we're finding zeros of a function, so knowing if it's a function is very important. Once we know that it's a function, if we're trying to find the zeros of said function, we're going to set the entire thing equal to 0 and solve for our x. Zeros in this case, so the word here zeros, is the same thing as an x-intercept. So it's where we're crossing the x-axis. So we set our basically y value equal to 0. So here my f of x is basically like my y. So I'm going to set this to 0 instead. This is a quadratic trinomial, so because I've got a quadratic trinomial, I am going to try to do M&A. I do M&A, and it's not the most fun. I didn't do M&A because I'm super lazy, and if I'm super lazy and I don't want to do M&A, mostly because my students freak out when we have this 2 in the front, which is fine, because like it's not as easy. You have to split the middle, and sometimes that takes a while. So a lot of times from here, since we already know the quadratic formula, I'm totally fine with us just using the quadratic formula, so I'm going to do that right now. So I'm going to plug all of these numbers into my quadratic formula. And I'm going to start my simplifying. So luckily for me, I do know the square root of 361, or my calculator does at least, and so it does give me a solid 19. When I can combine the stuff on top, so the negative 13 and the positive 19, I can split the plus and minus up. So I'll have minus 13 plus 19 divided by 4. And then I'll do the same thing with the minus. I'm splitting up this plus minus because I know there are two situations there, and so I want to know the value for each. And so these are my two solutions. There's my zeros. So where I would be crossing the x-axis. The next bit, which I want to move this over a little maybe. My next bit, again, we're going to set this equal to 0 to find the zeros. In order to get to the t that's underneath the square root, I need to undo the square root. So the inverse of a square root is a square. 0 squared is still 0. And I just move over the 25. That one was nice. You do want to plug it back in just to triple check. So if I plug 25 back in for t, 25 minus 25 is 0. The square root of 0 would give me 0. And so that works out. The last one, I'm going to save for my kiddos because I like them more than people I don't know. We've already had this conversation. You might as well get over it if you're offended. All right, so when we are increasing and decreasing, so sometimes our functions kind of look like wobbly worms like this. And so the increasing is when the part where we have a positive slope. So where we're going up if we're reading left to right, and it's decreasing if it has a negative slope. We also have instances where we just have it going flat. So you may see this a lot in some piecewise functions or in, I don't know, graphs about data from statistics. You could see it on the news. So anytime we have a horizontal, so it's not really going up or down, it's just going left or right, that is a constant. So we're either increasing, going left and right, decreasing, or we're staying constant and it's flat. We also have relative maxes and mins. So whenever we have those peaks and valleys, it may just be a slight peak or a slight valley. So we're going up, down, and then we keep going up this way or down that way. So we have a relative max that is the highest between two values, but then we know that it's not the actual maximum because we have this arrow that keeps going up. We have a relative minimum over here between two x values, but we know it's not the minimum because this arrow keeps going down. So it's what we call relative min, relative max. We see these peaks and valleys, and we find the x values of those peaks and valleys. So I have another example here of some of those peaks and valleys and the positive slopes and the negative slopes, so where we're increasing and decreasing. So I'm going to do the graphing utility with my students, and I'm going to talk about that with them because I have this nice TI-89 on my projector that I use with them. So I'm going to do that with my kiddos. Average rate of change is the same thing that we call a slope. So when we talk about average rate of change, we know that our graph, if it's wibbly wobbly like this, it doesn't have an actual rate of change because it's going up and down and up and down. So we do an average rate of change by just comparing two of the different points on that graph. So that would be the change in y over the change in x, same as our slope always is. And so in this case, because we're talking about the functions, we're using that f of x instead of the y values. So I like to just find 2 points. I pick 2 x values, find their y's, and then I do this just the same way as I would any slope. But this is basically what we're finding. We're finding, it's called a secant line. And so we're finding that average by using these points here. So this would be x1 and f of x1, or y1, if you will, and x2 and f of x2. So down here, I'm going to do one of these with you guys, and then the other one I'm going to make sure I do with my kiddos. So the first point that they want me to find is when x is -3. So I'm going to plug -3 into the x values of the function they gave me up here. So then my point here, when I plugged in -3, I got +3. So this is like my x1, y1. And then I need to do the same thing for the second. So my second point is going to be -2, 0. I plugged in -2 and I ended up with 0 in the end. So then now my last bit, that's my x2, y2, my last bit is going to be to find the slope of these 2 points. So I've got my change of y at the top and my change of x in the bottom. And then we're done. I got my slope for my average rate of change. And so the second one I'm going to do with my kiddos. Last thing that we're going to go over is even functions versus odd functions. So these are our equations on how to tell if something is even or odd. So if I take the original function and I plug in a negative x instead of the positive x, and then if that's equal to the original function, then it's going to be even. If I make the entire original function negative, then it's equal to if I had plugged in just a negative x, then it's going to be an odd function. And so I'm going to show you here with this first example on whether it's even or odd. So the first thing I like to do is test if it's even, and it's either even, odd, or neither. It's never going to be both. So if you plug it in and you see that it's even, then you're done. You don't have to test to see if it's odd because you already know it's even. So because of that, I like to just do the even part first. So instead of just x, I'm changing it out with negative x. So everywhere I have an x, I'm going to put negative x instead. So whenever I solve this out, negative x cubed is still going to be that, just negative x cubed. And so that's going to be -2x cubed. So here, this is basically the same. This isn't the same as the original function. So this is not equal to the original f of x. Everything was positive in the original f of x. So because that doesn't work, I know it's not even. But it does look like if I had just made everything negative. So I'm going to triple check and I'm going to do the test for the odd. So making the entire thing negative and see if it's equal to that. And if they are equal, then it is going to be an odd function. So I'm basically just multiplying the entire function by -1 by doing this. And this is equal to that f of -x. So because those are equal, then this is an odd function. And then this last one I'm going to do with my kiddos. So I hope you guys have a wonderful rest of whatever it is. If you found this helpful, then please like and subscribe. If you think it could be helpful for someone else, please feel free to share it. Spread that love.